The standard summation results to show this expression here. So you get some of these on the formula sheet, some of them we have to know. But this sum you can split up into 3 times the sum of r squared minus 17 times the sum of r minus 25 times the sum of 1. The sum of r squared is on your formula sheet, so 6n plus 1, 2n plus 1. The sum of r you need to know is a half n plus 1. And the sum of 1 from 1 up to n is just n. 3 over 6, I'm going to simplify to a half. And I want all of these to be something over 2. So I've got a half, I've got 17 over 2, and this 25 I'm going to write as 50 over 2, so that I can factorize out the half when I'm simplifying this. Factorize out everything that you've got in common with these as well, which is just n for these 3 terms. And then everything else goes inside a bracket. So you've got n plus 1, 2n plus 1 from the first one. And the second one, you've got 17 left in the n plus 1, so minus 17n plus 1. And from the last one, you've got a minus 50. Expand out what's inside those brackets. So 2n squared plus 3n plus 1 minus 17n minus 17 minus 50. And then tidy this up. So a half n 2n squared minus 14n minus 66. And you can factorize out 2 and times by the half. So you get n squared minus 7n minus 33. So A is minus 7, so A is just 7, and B is 33. Part B wants us to explain this expression here. So let's start subbing a few numbers in and seeing what happens. If we sub in r is 1, that's 1 times tan 60. Which is root 3. If you sub in r is 2, you get tan 120, which is minus root 3. So you get minus 2 root 3. If you sub in 3, you get plus 3 tan 180, which is 0. If you keep going, if you sub in 4, you'll get 4 tan 240, which is root 3. 4 root 3, sorry. If you sub in 5, you'll get 5 tan 300, which is minus 5 root 3. And if you sub in tan is 6, you get tan 360, which is 0. Notice what's going to happen here is that every time, in fact, all 3 of these numbers, including the 0, is going to give you minus root 3. This is minus root 3 as well. It goes up to 3k, so this will happen k times. So you end up with minus root 3k or minus k root 3. This will happen every 3 terms. So it will happen k times. Just a bit of explanation because it's an explain question. Then part C, it asks us to determine any value of n that satisfies this equation here. So on the left hand side, this is what we did in the first question, except it starts at 5 instead of 1. Remember, to deal with this, we do the sum up to from 1 up to n minus the first 4 terms this time. Okay. So the sum from 1 up to n is our result from part A. So that's n n squared minus 7n minus 33. And the sum from 1 up to 4, you can get from subbing 4 into this formula. So minus 4 times 4 squared minus 33. And if you work this out, minus 180. So this will give you this minus 180 so plus 180. So this is the left hand side. For the right hand side, we've seen this before, so this is from part B, except again it doesn't start at 1, it starts at 6. So this is the sum from 3n from r equals 6 is the same as the sum from r equals 1 minus the first 5 terms. Now we've written out the first 5 terms up here, to be honest. The first 5 terms here, you'll get minus root 3 from the first 2, then a 0, then another minus root 3. So this is minus 2 root 3. And this is minus k root 3. Sorry, minus n root 3 rather than k. Let's put all this together now. So the left-hand side we said is n squared minus 7n minus 33 plus 180. The right-hand side is 15 times this squared. 15 times minus n root 3 plus 2 root 3 squared. In fact, I could factorize the 3 out and square it. So that's 45. 2 minus n. Let's expand all this out and we'll get a cubic for this. So n cubed minus 7n squared minus 33n plus 180 equals, expanding this out will give me 45n squared minus 180n and then plus 180. These 180s cancel, bring everything over to the left hand side. See this? Obviously, n equals 0 is a solution to this. We can use our calculator to get the other ones. So we've got n cubed, sorry, minus 52 n squared plus 147. Gives us 49, 3 and 0. Only one of these is okay. So n equals 0 doesn't work if you sub it into the sum. You can't put it in the top. N is 3 also doesn't work. You can't have that because we're starting at 5 and 6. So the only solution that works for this is n equals 49.